Having worked on this AI for so long, it's hard to walk away from it without really feeling like it's finished, but I think the time has come that I need to move on to other things, and perhaps stepping away from it for a while will actually help me approach it with a better perspective in the future. But I think even as I come back to it, I'm going to be working on it more incrementally going forward. I'm going to be making improvements here or there rather than radical changes, because it is most of the way there. It's come a long way since last week, but it does still need some work. But before I go into what might be my last major AI update, I want to talk about some issues I found with GDNative, specifically memory leaks. It took me a very long time to figure out where the memory leaks were, because most of the tools I use won't work when Godot is doing the allocations within its own memory pools, and there's cross-DLL stuff, etc. It's hard, and I ended up doing things the hard way by commenting out code piece by piece until the leaks went away. Well, ultimately I found out that one of the causes was a known leak in string concatenation, which kind of shocks me. That seems like a very common thing. If anybody is using GDNative, they're probably concatenating strings somewhere, and if that's causing leaks, yikes. And as far as I can tell, the fix for that hasn't been taken into any master branch yet, although someone has posted a fix, which I incorporated locally to fix it for myself. But the other major memory leak I found was with dictionaries, and as far as I can tell, this is not a known issue. I'm going to do some more experimentation to really nail down exactly what's going on, but it seems to be a reference counting issue whenever a dictionary is cast to a variant. And I think there may be some other cases where leaks happen as well, but I haven't proven that with confidence yet. So I'll spend a little more time with that and then probably end up reporting a bug. Maybe I'll try to fix it myself. Not sure yet. For now, I'm working around that by replacing my own usage of dictionaries with a map and forbidding any objects from storing a dictionary-based state. Once I got my memory leaks under control, my next stumbling block was with an attempt at a fast line of sight check, because going through the raycasting seemed a bit slow, and I figured I could just walk the tiles that the line of fire would go through and check that way. Well, it turns out that none of the line tracing algorithms I found actually do what I want. They'll either check too few cells if they're not an anti-aliasing algorithm, or too many if they are anti-aliasing. There's probably an algorithm for what I'm trying to do out there somewhere, but for now I'm using my own that's not super efficient, but it's fast enough. In fact, I'm getting pretty decent performance even on debug builds for now, so I haven't tested release in a while. I'm sure it's going to be even faster. So now let's talk about the latest big challenge to my AI approach. The problem is with that gravitate function I showed last week. It would contribute to the score based on proximity to items of value. Well, the problem is, if a unit is surrounded by a bunch of crates, the proximity score of being close to the crates is more than the score of actually holding a crate, so it would consider it better to just stand in the middle of them than to actually pick one up. Because of course, once it's carrying a crate, it can't pick up a second one, so that proximity score goes away. So I thought about a few different ways to approach this. The first was to divide the score into tiers, such that important things like actually carrying the cargo to the destination or killing an enemy unit would always be prioritized above just being near things, no matter how many things or how much their total score would be. But the problem there is with threat scoring, because if I consider the threat to a unit to be part of its tier 0 or top tier score, then it will never move toward anything that could put it in more danger, even if the end result of going there and then doing another action is valuable enough to be worth it. But then if I put the threat score on a lower tier, it would be essentially ignored whenever there's any action that can be done without moving. I'm oversimplifying a bit here, but in short, I don't think that approach is going to work. My next idea was to change how gravitate works to ensure that only one object contributes to a proximity score per unit. But as I thought about that more, I realized that this whole gravitate concept goes back to one of the flaws I had before, where it's estimating value based on some future action without really taking into account all the consequences of following that through to completion. So a unit might be pulled toward a destination only to realize that at the end, being there has too much danger from enemy units to be worth whatever value was going to be achieved there. So a unit might end up moving back and forth between locations, being indecisive. Again, a problem that I had before. So I think I need to drop the gravitate concept completely. Now that left me with just one solution I can think of, which is basically the conclusion I came to before when I had the same problem. I need to simulate the full process of a unit moving somewhere and taking an action in order to properly score it. So what I'm doing now is converting more things to sort of meta actions. For instance, with the crate, instead of just one step at a time, the action it suggests to the AI will be the complete process of moving to the crate, picking it up, moving to a destination, and dropping it off. The good news is I already have the ability to simulate a sequence of actions on a hypothetical state, and most of the pieces I need were already in place. The big change now is that these actions can now span multiple turns. So the big thing I needed to change is when it's simulating spending of actions, it needs to account for whether or not a turn needs to be ended in order to get actions back to proceed. So far, this solution is promising. I got it implemented today, did some early testing, and so far I haven't found any problems with the approach, but there are still some bugs I need to work through. Mostly with the AI sometimes getting into a state where it doesn't think there are any useful actions left, even though there are. Part of the problem is weighing the danger of approaching an enemy unit versus the benefit of being within line of sight to attack that enemy. So I need to do some tweaking to how I score those things. Part of the problem may also be that some items are just too far away through too many steps of hacking doors and whatnot, that it's beyond the range that the AI considers as it's doing its hypothetical experiments. So I may end up just having the AI move units around sort of at random when it can't think of anything better to do. So that's where I'm going to leave it for this week. And I still haven't gotten to that game jam video yet because I've been just trying to get this AI done, but if I don't get to it today, I definitely will next week, probably on Monday. As always, it really helps if you hit the like button, spread the word, and subscribe if you haven't already. And of course, thanks for watching.